My unit is 4.8 synthetic division. Before getting to any problems, let's understand what synthetic division is. Synthetic division is the dividing of a polynomial by a binomial. Now, it's important to remember that synthetic division will only work if a polynomial is being divided by a binomial. So if it's a trinomial, it won't work. Synthetic division is also an easier and more efficient way to do long division. So this method is very helpful. Some problems are harder than others. However, with enough practice and awareness, they'll get easier. Now let's look at our first problem. As you can already see, there's a polynomial being divided by a binomial. So what you want to do to start off the equation is you want to get x in the binomial by itself. So to do that, you're just going to you're going to do -1 and you're going to get x equals a -1 because you got to get x by itself and isolate it. So what you're going to do with that -1 is you're going to take it over here and you're going to put it in this little half box area that we'll get back to later. So now we're going to go to this polynomial. And what you want to do is you want to look at the coefficients, which are these things right here, and that goes before the variable. So you want to put those right down here in orderly fashion. So as you can see, there's not 1 in front of this x cubed, but there's actually an imaginary 1 right there. And so you're going to put a 1 down here, and then a 3, another 3, and then finally a 1. So these are going to be your numbers that you're going to use to solve the equation. So then what you want to do to make it easier on yourself is you want to make a chart just like this, which will help you later in the problem. So now you want to solve it. To solve it, what you have to do is you're going to have to multiply and subtract or add and just repeat that over and over again. Let me show you. So in every synthetic division problem, the very first number that is right here, you're going to bring it down and it goes right here. So you bring down the first number, which is this one, and now you want to multiply it by this -1 that's in the half box that I said we'd get back to later. So 1 times -1 equals -1. Now right here, after you put it underneath the next number, you're going to do 3 minus 1, so that's going to give you a +2. 2 times -1 equals -2, and now 3 minus 2 gets you 1. 1 times a -1 gets you a -1, and finally 1 minus 1 gets you 0. This 0 is very important because this represents the remainder. Now, it's important because if a problem has a remainder, or if it doesn't have a remainder like this, then this means that this -1 is a solution to this problem right here. So that means x plus 1 is a factor to it. So that's what the remainder represents. So now to finish off this problem, we're going to have to put these numbers down here into standard form. So to do that, what you want to do is these are your new coefficients to your new answer. So this 1 actually represents just 1x. This 2 represents a +2, and then this 1 represents a +1. So now what you want to do though is you want to go up back to the original problem. So as you can see, it says the first number starts with x cubed. Well, when you go back down to your answer, you're actually going to subtract one exponent. So really, when you start this one off, it's going to say x squared. And now you just keep going down the line. So now it was x squared, but now it's going to be 2x by itself. And then you're going to go back down, and it says 3x. So now this one doesn't even get an x. So this right here is your fully simplified standard form. Now here's another equation, which is x to the 4th plus 3x cubed minus 9x minus 27 being divided by x plus 3. Polynomial divided by a binomial. So this is important to realize if we're doing any synthetic problem. As you can see, it goes x to the 4th plus x cubed, but then skips to -9x. There's no x squared right there. So what we need to do to fix that is we need a placeholder. A placeholder just fills in what's missing by putting in a 0 in its place. So 0x squared. So the right and proper equation should read x to the 4th plus 3x cubed plus 0x squared minus 9x minus 27, all being divided by x plus 3. Now we're going to solve like we did in the last problem. So what you want to do, like we did before, is first you want to get the x in this binomial isolated by itself. So subtract 3, x equals a -3. It's by itself. Put the -3 over in this box like we did before. Now remember, we want to bring down those coefficients plus that placeholder. It doesn't go away. So there's an imaginary 1 right here in front of the x to the 4th. So it's going to be 1. Then you bring down the 3. That 0 comes down as a 0 because we need it there. Then we bring down this negative 9 and then a negative 27. Now draw the chart and we can begin solving. So remember, in every synthetic division problem, you bring down the very first number. So this 1 is going to come down right here. Now you multiply and you do 1 times negative 3, which is a negative 3, which gives you 3 minus 3, which equals 0. And now you're just going to keep repeating all the way throughout the problem like we did in the last one. 0 times a negative 3 equals 0. 0 plus 0 equals 0. 0 times a negative 3 equals 0 again. Now negative 9 plus 0 gets you negative 9. Negative 9 times negative 3 gets you a positive 27. And now negative 27 plus 27 equals 0. Remember, this is the remainder, which is very important to remember. So now, like every synthetic division problem we do, we have to finish it off by putting it in standard form. So what we did in the last problem, we're going to do exactly the same thing here. In these purposes, I'm going to bring down every single thing, but later on, to make it faster for yourself, you don't have to. So you bring down this 1, which will be 1x. You bring down this 0. You bring down this 0. And you bring down this negative 9. And remember, this is a remainder, so it doesn't have to come down or anything. So now you want to go back to the original problem and see that said x to the 4th. Well, remember, like what I said, you subtract one exponent when you're writing it in standard form at the very bottom. So it's going to be 1x to the 3rd, and then you go on, so plus 0x squared plus 0x minus 9. Now you don't have to write these 0 x's because that really means that these x squared and x is not here. So really the equation is going to read x cubed minus 9. And that right there is your fully simplified answer. And with this answer, you can see that with this remainder, that negative 3 is a solution to this problem right here, and x plus 3 is a factor. So now, what happens when you don't actually get a 0, and you actually get a remainder? Well, that means that this number right here is not a solution to this equation. Let me show you what I mean. So first, like I did in the last one, let's realize and notice if we need any placeholders. As you can see, it goes 9x squared minus 3x plus 11. So it does not need any because all the numbers are right. And then this is all being divided by x minus 6. Polynomial divided by binomial. So we want to begin by isolating this like every single problem. So plus 6 on both sides, x equals 6. So put 6 in the box over here. Now let's do what we did in every single one and bring down the coefficients in each one right here. So we're going to bring down the 9, bring down the 3, negative 3, bring down the 11, and there we go. Now finish it off with this chart. So now, like in every single one, we bring down the very first number right here, which is this 9. Now we do 9 times 6, which equals 54. Negative 3 plus 54 equals 51. And now 51 times 6 equals 306. Now 306 plus 11 gets you 317. As you can see, we didn't get that perfect 0. I'm going to show you what we do with that in a second. But first, like in every other case, let's put it in standard form first. So we want to bring down this 9 because it's going to be the new leading coefficient. And now you want to look back at the original problem. As you can see, the first number had an x squared, so now you're going to minus an exponent. So it's really just going to read 9x. Bring down this 51, so it's going to be plus 51. As you can see, it was x, but now it doesn't get an x. So now what do we do with this remainder? Well, what you want to do is you want to put it at the end of this equation right here. So it's a positive, so it's going to say plus. But what you want to do with it is you're actually going to put the remainder over the original binomial in the problem. So it's going to be 317 over x minus 6. And that right there is your standard form simplified answer. So as you can see, you want to do this in every single problem that has a remainder. You put the remainder over the binomial. And as you can see, this problem is telling us that 6 is not a solution to this polynomial right here. Now in this last problem, we're going to add in those dreadful fractions that no one seems to like. But you'll come to realize that they're actually not that bad. So let's realize if we need any placeholders. And as you can see, it goes 4x to the fourth minus 17x squared. And right there, it skips x cubed. So what we want in that place would be a 0x cubed, because you fill in a 0 for the number. So the real number is going to read 4x to the fourth plus 0x cubed minus 17x squared plus 14x minus 3 divided by 2x minus 3. So now that we have the proper equation, let's begin solving it. So remember, like every single one, you want to get x on this side of the binomial by itself. As you can see, it's a little weird because it has a leading coefficient of 2 in front of it, but that's not going to stop us from isolating it. So you're going to want to add 3 to both sides, so 2x equals 3. And now you just want to divide by 2, so x equals 3 halves. And now this is important because when you divide this side by 2, you're actually dividing this whole problem by 2. And as you can see by these numbers, those aren't really fun numbers to divide by 2. Negative 3, negative 17, that's going to give you some weird fractions that you probably don't want to work with. So to save you some time and maybe be a little easier for you, you can actually save this dividing by 2 of all of it for the very end of the equation. Let me show you. So we're still going to solve this like every single problem we've already done. So the x equals 3 halves goes in that half box over there. And now you're going to bring down the coefficients that are up here in the polynomial. So you're going to bring down the 4, bring down the 0, bring down the negative 17, bring down the 14, and finally bring down a negative 3. All in a chart right here. So as you can see, there's a fraction. You're already thinking, oh, I'm going to have to multiply by the fractions. That's going to be really hard. But actually, it's not. So remember, you bring down the first number, which is this 4, and then that's in every synthetic problem. So now, when you multiply it, you're actually going to multiply this by the numerator, which is 3, which gives you 12. And now you're just going to divide it by 2, which is the denominator. So 4 times 3, 12, divided by 2 gets you 6. Now, you do 6 plus 0, which gives you 6. Now look, now you're going to do 6 times 3, which equals 18, divided by 2, just gives you a positive 9. So now you're going to do negative 17 plus 9, which gives you a negative 8. Negative 8 times 3 equals negative 24 divided by 2 equals a negative 12. Now 14 minus 12 equals 2, positive 2. And now remember, 2 times the numerator, which is 3, divided by the denominator. Well, 2 times 3 equals 6, divided by the denominator, which is 3. So you get a positive 3, and then negative 3 plus 3 gives you a remainder of 0. So that means 3 halves is a solution to this polynomial right here. Now remember when we divided up here by 2, and I told you that we had to divide the whole problem by 2 right then or at the end. Well, this is the end, and this is the time you divide it by 2. So 4 divided by 2 obviously gives you 2. 6 divided by 2 equals 3. Negative 8 divided by 2 is a negative 4. 2 divided by 2 gives you a 1. So there you go. So now this is the step where you just put it into the standard form. So you're going to look back at the original problem. As you can see, it started with x to the fourth. So subtract one exponent, and it's going to be x cubed. So you're going to bring down the leading coefficient with it. 2x cubed. Go back up. It was x cubed. So now this one's going to be x squared. So plus 3x squared. And just keep going down descending order. So then minus 4x. And then plus 1. And as you can see, there was no remainder, so there's nothing you need to add at the end of this problem. And this right here is actually your simplified standard form problem answer. See, the fractions weren't even that bad. It wasn't hard just to multiply this number by the numerator and divide it by the denominator. And that's how you're going to do it in every single problem that you have a fraction with. Remember, when doing any synthetic division problem, is to always notice or realize if you need any placeholders, and when you do, you put a 0 in for the place that you need it. Then remember that you want to isolate the x in the binomial by itself, and remember that it's polynomial divided by binomial, no trinomials or anything above binomial, because it won't work. Now remember, if you get a remainder for the end of the problem, then what you want to do is you want to put that remainder over the original binomial, and you'll do that for every single one. And finally remember, that fractions aren't that bad and there's no reason to be scared of them.